some more examples. Which order pairs are solutions? 3 comma negative 1, negative 4 comma negative 2, and negative 2 comma negative 4 for 4x minus 5y equals 7 and 3x plus 2y equals negative 16. So that implies that we're basically just checking to see if they work for those particular equations. So we have three different coordinates. Our equations, 4x minus 5y equals 7 and 3x plus 2y equals negative 16 first. And the coordinates that we're checking, 3 comma negative 1, negative 4 comma negative 2, and negative 2 comma negative 5. And I'll set them up like a table. That way it's easier to visualize in this case. So let's try the first coordinate. And let's see if it works for the first equation. Be aware, we're looking for where these two graphs intersect each other. These two equations, in other words. So not quite graphs, but equations. So where do they intersect? Let's see if we have the solution here. If we substitute the values of the x and y values, 3 and negative 1 in this case, for the equation. On the left side, we have 4 times 3 minus 5 times negative 1 equals 7. Now let's simplify. 4 times 3 gives us 12. Negative 5 times negative 1, negative is positive. 5 times 1 is 5. 12 plus 5 gives us 17, agreed. Does 17 equals 7? No, that's a false statement. Doesn't work. You can cross off the equal sign to say it's false, or state that it's false. So in this case, this coordinate did not work for the first equation. There is no reason to check the second one. You're welcome to do it though, but you're doing extra work. But if I were to check the second one, I would already know that it doesn't work for the first one. So it's got to work for both equations. Be aware of that. We're looking for the solution of both equations, not just one. So let's say I try the next one, and this one works. If it works for this one, then I'll try the second equation. Otherwise, I won't, because it'll be extra time. So let's try this out. Substituting the x and y values into the equation at the left side, 4x minus 5y equals 7. So it becomes 4 times negative 4, and then negative 5 times negative 2 equals 7. So 4 times negative 4, 4 times 4, 16, negative 16. And negative times a negative gives us positive. 5 times 2 is 10, so 10. So we get negative 16 plus 10 equals 7. Let's see if it's true. Negative 16 plus 10 gives us negative 6. Does negative 6 equal 7? No, that's a false statement once again. So this coordinate doesn't work either. So we don't need to work at trying to see if it works on the second equation. That's it. It doesn't work. Because it has to work once again for both equations. So let's go for the last case. Hopefully this one works. So 4 times negative 2 and then negative 5 times negative 5. Okay, so once again, we substituted for the equation at the very left. Okay, and we're getting that 4 times negative 2 is going to give us negative 8. Negative 5 times negative 5 is going to give us positive 25. So negative 8 plus 25 will give us a total of 17. Does 17 equal 7 once again? Nope. That's a false statement once again. So in this case, none of them seem to work, agreed? So keep in mind, it must work for both equations, not just one. So in this case, once again, none worked. So none of these equations are none of the coordinates are a solution to the equations. Be aware, in this case, they didn't ask us to find a solution. The question is, are these coordinates, or coordinate pairs, solutions for both equations, okay? And we just checked that they're not. So we're pretty much done for that particular question. Going on for the next one then. Find the solution of the system by graphing the equations by hand. 4x minus y equals negative 9 and 2x plus y equals negative 3. Okay, so let's try plotting them. And I'll do in the next one. So let's see, right here, we'll plot them on this graph. That'll make it easier, having graph. Okay, so let's graph them. Keep in mind our equation, y equals mx plus b is the general format. It's the slope-intercept. This is for reference. We want to write at the top of our page. So that way we know it's the equation that we're using for reference. And let's see, 2x plus y equals negative 3 is one of the equations we previously had, and 4x minus y equals negative 9 is the other one. Are they in the form of slope-intercept? Are they in the form of y equals mx plus b? No. So we won't be able to graph. Well, we could be able to graph. We can graph if we make a table, right? You get your pick x values. Let's say, for example, 0, 1, 2, your choice on the numbers though. And you can plug them in and make two tables and then plot them on the graph that's on the left side. You're welcome to do that, it still works. But for this case, I want to write in y equals mx plus b format, slope intercept. That way it's easier to see later on with our calculators to double check. So let me get rid of the 4x on the left side equation, minus 4x from both sides. And that will give us that negative y equals negative 4x minus 9. You're welcome to have it in reverse order, meaning you can go negative 9 minus 4x, but we want to have it in slope-intercept format, which you have the mx first and then the v value. So notice, when I rotated the 9 to the back, it did not change the sign. It's still negative 9, okay? But now I want to get rid of the negative from the y. Remember, it's like adding a 1 in front of it, or between the negative and the y. So now let's get rid of the negative 1 then. Be a division, right? Because it's multiplying with a y. Opposite, divide. And we're dividing to everything, preferably everything individually. It'll make your life easier. Negative 1 divided by negative 1 cancels out. And therefore, on the right side, we have negative 4x divided by negative 1. Well, negative and negative makes it positive. 4 divided by 1 gives us 4. And then the last part of that, 9 divided by 1, still 9, but negative divided by negative is a positive 9. So there's our formula then in slope-intercept format. Y equals 4x plus 9. Okay, and let's realize that our slope then, now we can define what our slope is and make it a lot easier to plot or graph. Our slope is 4, it's just a 4 next to the x, agreed, m equals 4. And you can always put it over 1 to have it in rise over run format. Y-intercept, 0, 9. So it's the 9 at the end, the v value, agreed? So let's go ahead and solve the other one for y. So let's get rid of the 2x, so minus 2x from both sides of the equation. And now that we've gotten rid of the 2x, that leaves us with just y. Y equals negative 3 minus 2x. Once again, sort of what I was talking about earlier. We want to have it in slope-intercept format, meaning the mx is first before the v value, right? So I'm just going to rotate this. I'm going to rotate it so that the negative 2x is first and then the negative 3. Notice, since I rotated in the same side of the equal sign, I just kept the signs along with the numbers or numbers with variables, and they don't change sign. They only change sign when you're passing from one side of the equal sign to the other. Be aware of that. So now we have the equation y equals negative 2x minus 3. And this is a better form of it, right? Slope-intercept format. It's easier to read the slope, which is negative 2, and we can always put over 1 to have it in rise over run format. And let's realize that the y-intercept is 0, negative 3. Once again, remember, you always have a 0 for the y-intercept. Okay? And in this case, the v value is a negative 3. So now we're ready to plot it. Since we have the slope and the y-intercept for each. Let's just realize that I'm going to graph one of them in blue and the other one in green. So there are the labels. Which one's blue, which one's green. So x and y axis labels. And let's start with the blue one. Blue y-intercept, 0, 9. But I won't be able to go up 4 over 1 anymore because I'm pretty close to the limit of my graph there. So instead I'm going to go reverse order. Down 1, 2, 3, 4, and back 1. Reverse order once again. Down 1, 2, 3, 4, and back 1. And now we can trace a line through that. But let's first go to the next one. Let's graph the other point. So there's a y-intercept, 0, negative 3. It's a green dot there that you see at y value of negative 3. And our slope tells us to go down 2 over 1. So down 1, 2 over 1, there's our next dot. And repeat it again. Down 1, 2, and over 1, there's our next dot. And now we can trace a line through them. Hey, look at that. We can see where they intersect each other. It happens to be one of the dots we placed on there. So let me put it in red. There we go. Red dot. That way you can actually see where it's at. So visually I can see it's at x is negative 2 and y is positive 1. So our answer, our intersection point is negative 2, 1. So there is our answer for this particular case. This case, we found out that this is a consistent system with one solution. So single answer.